Hello guys and welcome to a new session of physics. Our lesson today is properties of matter. First of all, I need to know what are the states of matter and how do they differ from each other. Scan the QR code and watch the videos and turn back to me. We have three different states of matter. The first state of matter is solid, then liquid, then gas. The state of matter depends on the motion of particles. As particles gain more kinetic energy, move apart from each other, move away, so the state of the matter change, as we said before in the last session. So the state of matter in front of you guys is a solid state. By heating it up, the motion of the particles increase and its kinetic energy also increase. So it changes from being solid into liquid. By adding more heat, it changes into gaseous state. So I'm starting with solid, increasing the temperature of solid, the motion of particle increases. By the same way for liquid, and also for gas is the same. States of matter. We have three different states of matter: solid, liquid, and gas. The difference between them according to the motion and intermolecular forces. As particles of solid remain fixed position, but liquid slightly move, and gas, the particles have free motion. Intermolecular forces between the particles of solid, very strong; for liquid, moderate; and for gas, very weak. The shape for solid is fixed shape. Liquid takes the shape of container, and also gas takes the shape of container. The volume of solid is fixed, while the liquid, the volume also is fixed, while the gas occupies the volume of container. Moving to another part called pressure. What is the pressure, guys? Pressure is the force which is act perpendicular to the unit of area. I'll ask you guys a question. A lady with high heel will form a higher pressure than an elephant or a lower pressure? Of course, a woman with high heel forms a high pressure than, or a pressure higher than, which formed by an elephant. As guys, we said, the pressure is equal to force by unit area. As the unit area decrease, the pressure increase. So the high heel provides a very small area which makes the pressure very high. So how to define pressure, guys? Pressure is the perpendicular component of force on a surface divided by the area of the surface. The SI unit of pressure is Pascal, and also it can measured in Newton per meter square. We said pressure is the force which acting perpendicular to the unit of area. Perpendicular. So P equal F over A. But if the force is formed with an angle to the surface, here is the force applied. So, as we said before, we are unable to deal with a force in two dimensions or any vector quantity in two dimensions. So I have to return it back to one dimension. Returning back to the previous state as the angle between the perpendicular, the vertical, and the force itself, so it will be cosine theta. Now I need to find the component of y. So the component of Fy which is applied perpendicular, is equal to F cosine theta. Returning back and applying on the rule, P equal F cosine theta over A. So if the force is applied perpendicular to the surface, the rule of pressure will be P equal F over A. If the force is applied with an angle to the vertical, so I'm going to use cosine theta, and the pressure will be F cosine theta over A. What is the meaning of ideal gas? Ideal gas, guys, is a gas whose particles take up no space, which means the volume is neglected. The volume is what? Is neglected. So the volume is not considered in our calculation. And also, there is no intermolecular attractive force. Let's know, guys, what is the meaning of a pressure of a gas inside a container. Let's say that we have a container, and this container contains gas. The particles of gas are in random motion, so it's going to collide with the walls of container. By colliding with the walls of container, it makes a pressure on the inner side of the container. So it provides the pressure of gas inside the container. So the pressure of a gas inside container is resulted from the number of collisions of particles inside the container with the walls of the container. Moving to a new part, guys, which is gas laws. Gas laws are three laws which provide a relation between pressure and volume of gas at constant temperature, and called Boyle's law. Relation between volume and temperature at constant pressure, which is Charles' law, and relation between pressure and temperature at constant volume, which is called Jean-Lazare law. Let's find firstly the relation between P and V. Here we have some gases, guys, some particles of gas, certain gas, and I will make the temperature constant. By decreasing the volume, the pressure increases. Notice the pressure value at the right side. By increasing the volume, the pressure decreases. So the relation between pressure and volume is an inverse relation. As the pressure increases, guys, the volume decreases, or even though as the volume increases, the pressure decreases. Moving to find the relation between volume and temperature. Charles, here, guys, I'm going to make the pressure constant. By adding more heat, the volume increases. So the relation between heat and volume. Moving to the third law, which is Jean-Lazare law, the relation between pressure and temperature is directly by adding more heat at a constant volume, guys, the number of collision with the walls of container will increase. This number of collision provides the gas pressure. So the gas pressure will increase by increasing the temperature of the gas. Adding more heat, more kinetic energy is gained by particles, so the pressure also increases. So, guys, we can combine all of these laws, the three laws, Boyle's law, Charles' law, and Jean-Lazare law, in one rule, and we call it combined gas law or general law of gases, which is P1 V1 over T1 equal P2 V2 over T2, which equals to a constant value. How to differentiate, guys, between ideal gas and non-ideal gas? Definition. Ideal gas is a gas that follows the ideal gas laws, PV equal nRT. While non-ideal gas is a gas that deviates from the ideal gas law. Intermolecular forces in ideal gas assumed to be negligible. There is no intermolecular forces. The volume, gas particles, considered a point mass. So it has no volume, but it has a mass. Behavior at high pressure continues to obey the ideal gas law, and we are going to study the ideal gas law. Behavior at low temperature continues to behave ideally. Examples: hydrogen gas, helium gas at standard condition. What are standard condition? What atmospheric pressure and 25 degrees Celsius, which is called room temperature. Non-ideal gas, guys. A gas that deviates from ideal gas laws, especially at high pressure and low temperature. Significant intermolecular forces exist affecting the gas behavior. Volume. Gas particles have finite volume, which affects the gas behavior. Behavior at high pressure deviates because the volume of molecules become significant, which is mean. The main difference between ideal gas and non-ideal gas is the volume and intermolecular forces. Ideal gas has no volume, has only mass, and has no intermolecular forces, while the non-ideal gas has both of them. Here is the ideal gas law, guys. PV equal nRT. We said before, guys, the general law of gases says that PV over T is equal to constant. This constant is NR. NR. N is the number of moles, while R is gas constant. Is gas constant. So, PV equal nRT, which represents the ideal gas law. If you would like to change the form of ideal gas law, instead of being PV equal nRT to be in Avogadro's form, using Avogadro's number. Avogadro's number is number of particles in 1 mole of matter. We said before, guys, PV equal nRT, which is N equal to number of moles. So, number of moles can be found by dividing the total number of particles by Avogadro's number. So, the rule now will be N, total number of moles, divided by Na, Avogadro's number, multiplied by constant gas law and temperature. While guys, R over Na is a constant called Boltzmann constant. Boltzmann constant. And simplified by K. So K is equal to R over Na, which is equal to 1.38 times 10 to the power negative 23. Dividing the gas constant, ideal gas constant, 8.314 by the Avogadro's number, 6.02 times 10 to the power 23 particle per mole. Freezing of water, guys. Scan the QR code and then return back to me. Watch the video and then return back to me. Water molecules, guys, has a structure of pin shape. As you studied in chemistry, O is a high electronegative atom which attracts the bond electrons towards itself. So it has a partial negative, while hydrogen has partial positive charge. We have multiple molecules of water. So we have a lot of molecules of water. Hydrogen in this case can locate it between two oxygen atoms of high electronegativity. So it can form something called hydrogen bond. As the hydrogen bond is the bond which is formed when hydrogen is located between two atoms of high electronegativity. And this hydrogen bond is electrostatic attraction force. Forming this hydrogen bond makes ice shaped by crystal figure, form something called a crystal lattice. This crystal lattice increases the size of solid instead of decreasing. It keeps the molecules of water away from each other to form the shape of crystal. To form the shape of crystal. Freezing of water. When water is heated from 0 to 4 in a state of expanding, it contracts as the force between particles increases and the ice crystals collapse. These force between water molecules are strong, and crystals that make up ice have very open structure. So, as the water solidify, it forms crystals, and these crystals make the volume of solid, water solid, which is ice, greater than liquid. Let's solve some questions, guys. A gas has a volume of 4 liters in 1 atmospheric pressure. If the pressure is increased to atmospheric pressure, ATM mean atmospheric pressure, at constant temperature, what will the new volume be? Here, the temperature is constant, so I'm going to find the relation between P and V. P1, V1 equal P2, V2. P1 is 1, is equal to 1, and V1 is 4. B2 is 2, so the volume will be also 2. As the pressure increased, the volume decreased, as the relation between volume and the pressure is inverse relation. Well done. So the volume will be 2 liters. Charles' law states that at constant pressure, that means the relation between volume and temperature, V1 over T1 equal V2 over T2. The relation between volume and temperature is a direct relation. So, temperature is directly proportional to the volume. A gas at 300 Kelvin and 2 atmospheric pressure has its temperature increased to 450 Kelvin at constant volume. What will the new pressure be? So, let's find the givens. T1, P1, T2. Volume is constant. So the relation will be between P and T. P1 T1 equal P2 T2 over T2. P1 is equal to 2. T1 is equal to 300. While P2 is masked, unknown, T2 is 450. So P2 will equal to 450 times 2 divided by 300. The answer will be 3 atmospheric pressure. Guys, notice that during solving the problems of gases, gas laws, even to be the ideal gas law or J. Lozak, Charles law, the temperature must be substituted in Kelvin. The temperature must be substituted in Kelvin. So if he provided the temperature in Celsius, you have to convert it into Kelvin to be able to use it to solve the problem. Forces within liquids, guys. We have 2 forces. One of them is called cohesive force, and the other one is adhesive force. What is the difference between cohesive force and adhesive force? Cohesive force, guys, is the force between the molecules of the same substance. So it's attraction force between particles of the same fluids, even to be liquid or gas. In real fluids, particles exert electromagnetic forces of attraction called cohesive force. So it's an electromagnetic forces. In non-ideal fluids, The cohesive force and collision between fluids molecules cause internal friction that slows the fluid flow and dissipates mechanical energy. Dissipates, that means makes the mechanical energy converted into another form like heat. So the cohesive force now is the force, attraction force between the molecules of the same matter. Surface tension, guys, is a result of cohesive force. Let's say here is the surface of the liquid, and it is the liquid itself, particles of the liquid. This particle, guys, at the middle is attracted by different forces. One to the right, one upward, one downward, one to the left, another one to the left. So the forces which is attracting this particle are balanced. So the particle remains in its place. But if I'm talking about the particles at the surface, there are group of forces acting on these particles, even to be downward or horizontal. But there is no upward attraction force. So these particles keep moving towards each other, and the intermolecular distance between them decreases, and the intermolecular force increases. The intermolecular forces increases, which make these particles strongly attached to each other. This phenomenon is called surface tension. As the attraction force the attraction force between particles at the top of the surface is very strong. So the surface tension, guys, is the tendency of the surface of a liquid to contract to the smallest possible area. Beneath the surface of the liquid, each particle of the liquid is attracted equally in all directions by neighboring particles and to all particles of the wall of container. There is a net force, downward force on the top layer, only top layer. The net force is downward, which causes the surface layer to be slightly compressed. Moving to another term, guys, physical term, guys, which is called viscosity. What is the viscosity? Viscosity is the measure of this internal friction. So viscosity is the ability of the particles of a medium to flow over each other. As the intermolecular force increases, that means this ability decreases. This ability decreases. So the particles became unable to flow over each other. Higher viscosity means lower flow rate. So water is not a viscous. Water flows fast. Motor oil is very viscous, so the oil flows slowly. Another type of attraction force, guys, called adhesive force. Adhesive force is the attraction force between the particles of a substance or a fluid and another fluid. So there are two different or more than two types of matter. So adhesive force is the second type of attraction force within fluids, which is electromagnetic attractive forces that act between particles of different substance. What is that, guys? Different substance. The adhesive force is responsible for something called, or a phenomenon called, capillary phenomenon. When immersing a thin tube inside a water pot, a water container. We found that the water rises up inside the tube. This rising up as a result of the attraction force between the water molecules and the molecules of container, which is called adhesive force, making the water flow up, is a result of that adhesive force is greater than cohesive force. The attraction force between the particles of water and the particles of container is greater than the attraction force between the particles of the water itself. So it makes the water rises up inside the tube. For example, when a glass tube is placed in a beaker of water, water climbs the outside of the tube. That means, guys, adhesive force is greater than cohesive force, as we said before. So, guys, the general gas laws formula is, well done, V1 V1 over T1 equal V2 V2 over T2. Boltzmann constant K is related to the gas constant as, well done again, K is equal to R over Avogadro's number, divided by Avogadro's number. A gas at 1 atmospheric pressure and 27 degrees Celsius is heated to 127 degrees. What will the final pressure be, assuming the volume of the gas is constant, remains constant? In this problem, guys, he provided the temperature, as we said before, in Celsius. So, let's solve it, firstly, with a wrong method, then find the answer, comparing it with the real one, or the true one. So, volume is constant, and I'm dealing with P1 over T1 equal P2 over T2. P1 is 1 over 27 equal to 127. So the answer will be 127 divided by 27. The new pressure will be almost 5 atmospheric pressure. The answer doesn't exist here. So let's write the wrong answer here, 5 point something. Let's solve the problem. After converting 27 and 127 in a state of Celsius to be Kelvin. Here it will be 300 Kelvin. And here will be 400 Kelvin. 400 Kelvin. By adding 273 to convert from Celsius to Kelvin. 1 P1 over T1, write the rule first, equal P2 over T2. P1 is 1 over 300 equal to unknown over 2 400. So the answer will be 400 divided by 300, which is 1.1 over 3. 1.1 over 3 is 1.33 atmospheric pressure. Let's find the true answer. So guys, be careful while reading the problem. In gas laws, we must convert Celsius into Kelvin. We must convert Celsius into Kelvin. The phenomenon of surface tension can be observed when paper clip float on water. The ability of liquid to resist flow is known as viscosity. Moving to another part, guys, which is Pascal principle. Pascal principle states that any change in pressure applied to any point on confident fluid is transferred undimensioned throughout the fluid. Which is mean, guys. Here I have a plate. This plate has an area of 1 centimeter squared. Below this plate is a liquid. And moving to the other side, this is another plate. The area of this plate is 2 centimeter squared. As we said before, guys, the pressure is the force applied on unit area. So here is the unit area, 1 centimeter squared. So if the force applied here is 10, it will be transferred by 10 Newton for each 1 centimeter squared. The resulted one here will be also 10 for this 1 centimeter squared and another 10 for this centimeter squared. So the resulted force will be 20 Newton instead of being 10 Newton. The pressure is the same. The pressure is the same. The pressure here is 10 Newton per each 1 centimeter squared. And also the pressure here is 10 Newton per each 1 centimeter squared. But by increasing the area, I multiplied the force for each 1 centimeter squared. So if I'm going to make this plate or piston 5 centimeters squared, so the force, the applied force will be multiplied 5 times. So Pascal stated that B is constant, so B1 at piston 1 equal P2 at piston 2. B1 is equal to F1 over A, while B2 is equal F2 over A. Here is A1 and here is A2. To have the same ratio as the A multiplied or increase, the force also increase. So Pascal principle is created and found to save and remain the pressure while multiplying the effort and force applied. So Pascal's principle states that any change in pressure applied at any point on a confident fluid is transferred undimensioned throughout the fluid. B1 equal B2, F1 over A1 equal F2 over A2. What is the meaning of buoyant force, guys? Buoyant force is the force created by the increase in pressure with increasing the depth. Let's say that buoyant force is found by the amount of water displaced by immersing a certain object inside the water or inside fluid. If the buoyant force is greater than the object weight, so the object will float. If the buoyant force less than the object weight, so the object will sink. If the buoyant force equal to the object weight, the object will remain in the middle of the water, just floating in the middle, not immersed down, moving down or moving up. How to calculate the buoyant force, guys? We said before, force is equal to M times V, times G. M is the object mass. If the object going to float, at the middle of the liquid, which is mean F force of buoyant force is equal to Fg. How to find the mass of the object? The mass of the object is equal to density multiplied by the volume of the object. I can have the density of the object itself, but I'm not able to find its volume as and if the object has a regular shape. But the volume of the liquid is the same volume and equal to the replaced volume. The replaced volume of the fluid. So we can say that Fg now is rho volume of fluid multiplied by G. Rho is the density of the object, which is equal to the buoyant force also. Let's check, guys, the buoyant force. We have a mass. This mass is 1.5 kilogram, made up of styrofoam. By decreasing the mass, the amount of water displaced decreases. By increasing the mass, the amount of water displaced increases. By increasing the density of the fluid itself, the amount of fluid displaced decreases as it pushes up the object upward. By decreasing the density, more amount of object immersed. The displaced volume increases. Changing the material itself, putting wood. More amount of wood is immersed and more water for the same volume of cube is replaced as more volume is immersed. I'm going to change it using brick instead of wood. So its density is very high and the water is unable to push it up, or the fluid is unable to push it. But increasing the density increases the buoyant force and make the object float as the buoyant force became a greater than its weight. So guys, buoyant force is the force created by the increase in pressure with increasing depth. As the depth increase, the pressure increase, and also the amount of volume of fluid displaced increased. So the buoyant force is equal to density of the fluid itself multiplied by the volume. Volume here can be considered as the immersed part or the immersed volume of the object, or the volume of displaced fluid multiplied by G, which is the acceleration of gravity. Archimedes' principle states that an object immersed in fluid has an upward force on it that is equal to the weight of the fluid displaced by the object. Bernoulli principle. Bernoulli principle is a relation between the fluid velocity and its pressure. As the velocity increases, the pressure decreases. The pressure exerted by this fluid decreases on the walls of container. As particles move faster, it became unable to make pressure and more collisions with the container walls, so its pressure decreases. If a certain mass of a smoothly flowing ideal fluid enters one end of the pipe, then an equal mass must come out. I'm talking about the mass. So, to make it come out, the same mass come out at the same time, so the velocity must increase. Suppose that pipe's cross-section become narrower. To keep the same mass of fluid moving through the narrow section in a fixed amount of time, in the same type of amount, the velocity must increase. By increasing this velocity, the pressure on the container decreases. The pressure on the walls of container decreases as particles move faster and the number of collisions decreases. If the network is positive, the pressure at the input end of the section where the velocity is lower must be larger than the pressure at the output where the velocity is higher. Applications of Bernoulli principle. Paint sprays, guys. I decrease the amount of pressure, but I increase the velocity. Perfume bottles, I decrease the pressure. The pressure inside the bottle itself is very high, but when you release the liquid, the pressure decreases and the velocity of the perfume increases. Which of the following is an example of situation where cohesive force are dominant? Dominant, that's mean greater. Water droplets forming on a glass window. A cube with a volume of 2 meter cube is fully submerged in water. The density of water is 1000 meter cube. What is the buoyant force acting on the cube? We said before, guys, the buoyant force is equal to rho of the liquid, of the fluid, multiplied by the volume, immersed volume, or displaced volume, multiplied by acceleration of gravity. Rho is 1000. The cube is fully submerged, so I will take whole of the volume, which is 0.2, multiplied by 9.8, which is mean 200 multiplied by 9.8. So the answer is less than 2000. So it will be 1960 Newton. In a hydraulic press, the input force is 50 Newton and the output force is 2500. The input force, which is mean force 1. Output force, force 2. If the input piston is 0.01 meter squared, that's mean area 1. What is the area 2? The output piston area. So Pascal's principle, F1 over A1 is equal to F2 over A2. F1, 50, divided by A1, which is 0.01, equal to F2, which is 2500, divided by area 2 of the output piston. So A2 will be 0.01 multiplied by 50. So the answer will be half meter squared. A seal ball sink in water because the density is greater than water. The density of the ball is greater than water. In a hydraulic lift, if the input force is treble, what happened to the output force? Also treble, as they are directly proportional. Water flows at 5 meters per second in 0.2 meters squared pipe. What is the flow rate of water? The speed is V, while the area is A. The flow rate is equal to area multiplied by fluid velocity. How much particles pass through this area? So it will be 0.2 multiplied by 5, and the answer will be 1 meter cube per second. Solids, guys. We said before, solids are substances which the intermolecular forces between particles is very strong. So the particles are unable to move and leave its position. It just vibrates in its position. Solids sometimes form something called crystal lattice. Crystal lattice is a fixed arrangement of particles due to the existence of intermolecular forces between the particles and the bonds within the particle itself. So, when the temperature of a liquid is low, the average kinetic energy of the particles decreases, and the cohesive force, which is the intermolecular forces, increase. The particles in a crystalline solid don't stop moving completely, rather they vibrate around their fixed position, as we said. We have another type of solid structure, which is called amorphous solid. In amorphous solid, a substance has no definite shape. They cannot form a crystalline or crystal structure. A substance which has no regular crystal structure, but they have a definite volume and shape, called amorphous solid. So they still solid and have the properties of solid, but they don't have crystalline shape. They don't have a definite shape. So we call amorphous. What is the meaning of elasticity? Elasticity is the ability of a solid object to return to its original form when the external force is removed, like a rubber. When you press a rubber, it bends down with you. When you remove your finger, it returns back to its previous shape, which is called a slight deformation. You just deform the crystal shape, deform the arrangement of particles beside each other. But if this amount of force applied, pressure exerted, increased to the amount which the crystal or the shape of the solid, the arrangement of the solid, unable to handle, it's called deformation, because you changed the shape, the inner shape of the solid. If too much deformation occurs, the object will not return to its original shape because the elastic limit has been exceeded. Now we are talking about the expansion, guys. Thermal expansion of solid. More heat added, more motion of particles, less intermolecular forces, so it expands. As a result, when particles vibrate more with increased temperature, their average separation increase and the solid expand. As we said, more heat added, temperature increase, motion of particles increase, so the solid expand. We have two coefficients or three coefficients of expansion. We have a linear coefficient and area coefficient and volume coefficient. So the coefficient of linear expansion alpha is equal to the change in the length of a solid divided by its original length and its change in temperature. The coefficient of expansion is equal to the change in length, which is equal to delta L, divided by original length, the change in temperature. So delta L is the change in length. L1 is the original length. Delta T is the change in temperature. The coefficient of volume expansion, beta. Beta is about 3 times of the coefficient of linear expansion because volume expands in 3 dimensions. So, by the same way, the volume expansion coefficient is the change in volume divided by the volume, the original volume, and the change in temperature. And the coefficient of volume expansion is defined as the change in the volume of solid divided by its original volume and the temperature change. Here is the 3 types of expansion. First one, I'm talking about the linear expansion. The linear expansion, delta L is the amount of the length increased, is equal to the linear expansion coefficient multiplied by the original length and the change in temperature. It's the same rule, guys. Alpha is equal to delta L divided by L delta T. It's the same. Area expansion for a flat surface. So alpha A is equal to delta A multiplied by delta T. Delta V is the volume expansion, alpha V, or beta, as we said before, V delta T. The primary difference between crystalline and amorphous solid, guys, is crystalline solid are always harder than amorphous solid. An iron cube has a volume of meters cubed. Here is the volume, guys. At 10 degrees, here's temperature. If the temperature increased to 30 degrees, so it increased by 20 degrees, V2. So delta T is 20 degrees. And the coefficient of the volume expansion is 3.6 times 10 to the power negative 5 Celsius. What will be the change in the object volume? So, as we said before, delta, let's say B is equal to delta V over V delta T. So, he asked about delta V. So, delta V is equal to beta V delta T. Beta is equal to 3.6 times 10 to the power negative 5 multiplied by the original volume, which is 0.02 meter cubed, multiplied by the change, which is 20. By finding the final result, it will be 0.002 meter cubed, guys. Waves, guys. What are waves, guys? Scan the QR code, watch the video, and return it back to me. Waves is a disturbance of medium particles, guys, that transfer energy. So the main function of any wave, guys, is transferring energy. During the wave, the energy only transferred, not the particle. We have two different types of motion, guys. Transitional motion, motion which we studied before, from one place to another place, like distance, displacement, velocity, and speed. And periodic motion. Periodic motion is the motion which is repeated at equal intervals of time. We have periodic motion, oscillatory motion, and simple harmonic motion. What is the difference between them, guys? Oscillatory motion is the movement of an object back and forth between two opposite points. Simple harmonic motion is the motion on one side of a resting point. So, if you have a point, and this is the resting point, and the amplitude. The motion of the object is the rest point, and it is an amplitude, the maximum displacement. The movement of the object between these 2 points back and forth called oscillatory motion. While the simple harmonic motion, like the motion of pendulum, we have a rest point and the pendulum oscillates at the 2 sides of the rest point. Some terms we need to know, guys. What is the periodic motion, or we call it period, T. It's a time. To move a periodic motion, which is mean you will return back to the original point, the starting point. Let's say we have a pendulum, and the pendulum going to move to right, then return back to left. By this way, this pendulum doesn't do a complete oscillation. This pendulum has to move at the other side to the maximum displacement and returns back to the original point. The time taken to make these 4 movements is called period. And this movement is called complete oscillation, or complete motion. So the periodic time is the time needed for an object to repeat one complete cycle, motion, oscillation of the motion. So the amplitude is the maximum displacement from the origin or the equilibrium position. Hooke's law measures the potential energy found in a spring. When you apply a force on a spring, that means there is a potential energy is stored inside the spring, makes it turns back to its original position when the force you applied is removed. When a force is applied to stretch a spring, such as by hanging an object on its end, there is a direct linear relation between the exerted force and the displacement. By increasing the force, the displacement also increases. So guys, if we said that, let's apply Huck's law. Here is a spring, and a force applies to the spring to make it stretch. So by increasing the force, the potential energy stored inside the spring also increase. And also by increasing the spring constant, the amount of potential energy increases. So the spring constant is the constant which represents how much the spring resists its expansion. As the constants increase, that means this spring resistance for expansion increase. The amount of potential energy stored also increases. So the spring constant, which depends on the stiffness and the other properties that the spring. X is the distance the spring is stretched from the equilibrium position or even compressed. By the end, the force applied is equal to negative kx. K, the spring constant, x, the displacement for stretching or compressing the spring. To find the potential energy on the spring, E equal to change in work, where work 2 minus work 1. Work in general is equal to half Fd. So by the end, the potential energy stored in the spring is equal to half kx squared. D is the distance moved by the spring, and we can substitute F by negative kx. So the potential energy, instead of being half Fd, will be half kx multiplied by d, which is also x. So it will be half kx squared. Moving to another concept, guys, which is the pendulum. And pendulum is representing the oscillatory motion, the harmonic motion, which is the motion at the two sides of equilibrium or rest point. Here is the pendulum, guys. When applying force on the pendulum to move away from the rest point, it's going to oscillate at the two sides of the stationary point or resting point or point of equilibrium. All of them are different names for the same physical term. Notice that, guys, the amount which the object displaced, right? Let's say 40 degrees, is the same amount will be displaced as the other side. All of this motion, guys, in the absence of friction. There is no friction, guys. As the wire length increases, the amplitude decreases. By decreasing the length of the wire, notice the time of one oscillation. The time of one oscillation calculated from the highest point to the highest point again of the same position, going from here left and turning back to the right again. Let's say that starting from this point, we're going to drop it down, moving to the other side, and return back to the same position. Represent one complete oscillation, and the time taken is the period time. The periodic time or the period itself. Notice the period time, guys. Notice the period. By decreasing the length, notice what will happen to the periodic time. The periodic time decreased. By increasing the length, the periodic time increased. There is a direct relation between the periodic time and the length. As the length increases, the periodic time increases. As the length of the wire decreases, the periodic time also decreases. And as we said before, as the length decreases, the amplitude increases. As the length decreases, the amplitude increases. So the rule which we use to find the rule which we use to find the periodic time is T 2 pi L over G, while L is the length of pendulum wire. So, as the length of the wire increases, the periodic time also increases. As the length of the wire decreases, the periodic time also decreases. A spring with a force constant K is stretched by displacement X. What is the potential energy stored in the spring? Half kx squared. In simple harmonic motion, the restoring force acting on the particle is proportional to the displacement of the particle itself. Let's say that, guys. Here is the pendulum, and here is the rest point. Moving the pendulum upward to the new position makes the potential energy stored is maximum. So the pendulum has the maximum potential energy at the maximum point. Let the pendulum moving down. The potential energy decreases to reach the origin point. At this point, the kinetic energy is maximum and the potential energy is almost equal to zero. Moving to the other side at the same position, but at the other side, at the same height, at the same displacement, but at the other side, the potential energy increases again to reach its maximum value, and the kinetic energy decreases to reach zero. So the kinetic energy here is equal to zero. The pendulum stops moving and change its direction, returning back to the original point, moving again back to the original point. What is the period of a simple pendulum of length L and gravitational acceleration G? 2 pi square root of L over G. Types of waves, guys. We said before, wave is a disturbance that carries energy through a matter or space. So the main function of wave is transferring energy. We have two types of waves, mechanical wave and electromagnetic wave. Mechanical wave is the type of wave which needs a medium to travel through. Electromagnetic wave is a type of wave which doesn't need a medium to travel through. Doesn't need a medium, that's mean it can travel through medium and it can travel through space. But mechanical wave, unable to travel through space. Mechanical wave depends on the medium particles vibration, guys. Types of mechanical wave. We have two types of mechanical wave. One of them is called transverse wave and the other one is called the longitudinal wave. Transverse wave, when the medium particles vibrate perpendicular to the wave direction. Wave direction is the direction at which the energy travels. When the medium particles vibrate up and down, that means it vibrates perpendicular to the wave direction. So we call it transverse wave. Transverse wave. But when the medium particle vibrate, here is the wave direction. When the medium particles vibrate forth and backward, so we said the medium particles vibrate along the direction or the same direction of energy transfer. So we called it longitudinal wave. So we have two types of mechanical wave, transverse wave and the longitudinal wave. Transverse wave is a type of wave which the medium particles vibrate perpendicular to the wave direction. Longitudinal wave is a type of wave which medium particles vibrate along the wave direction. Surface wave, guys. What is a surface wave? Surface wave has a characteristics of transverse wave and longitudinal wave. In this wave, the particles vibrate in two directions, perpendicular to the wave direction and along the wave direction, exactly like the water wave. Water waves, guys, there is the movement, there is the direction of transferring energy to the shore side. We can find that the particles of water vibrate up and down, and also it makes something similar to circulation. So it vibrates in a circular path, which is forward and backward along the direction of transferring energy. So we can say that the surface wave has the characteristics of both transverse wave, here is the transverse wave, up and down, and also something similar to circular motion, which is forward and backward. So the surface wave is a wave that has characteristics of both transverse and longitudinal wave. Component of transverse wave. The transverse wave consists of crest, trough. Crest is the maximum displacement upward in a certain position, and the trough is the maximum displacement at the opposite direction, downward. So the crest is the maximum displacement upward from the rest point, while trough is the maximum displacement from the rest point downward. What are the components of longitudinal wave? As we said, guys, longitudinal wave is the vibration of medium particles forward and backward. So it can make something called compression and rarefaction. Compression is the area which the particles are close to each other. Rarefaction is the area which the particles are away from each other. So compression is the area of the wave in which the particles are close to each other and compressed. Rarefaction is the area of the wave in which the particles are away from each other. Here is the wave, guys. We can form wave as this one. Notice the first concept which we are going to study is the amplitude. Amplitude, guys, is the maximum displacement from the reach point. The dotted line, this dotted line represents the rest point. And this distance, guys, represents the amplitude. This distance is similar to this distance and also similar to this distance. So the amplitude is the same in each position. So amplitude is the maximum displacement from the rest. Now I'm going to increase the amplitude, guys. Notice that the maximum displacement increased. The maximum displacement from the rest point is the amplitude. We can decrease the amplitude. Here is the amplitude. What is the frequency? The frequency is the number of waves by unit time. How many waves in unit time? I'm increasing the frequency. That's mean I'm increasing the number of waves, guys. Here is I'm changing the frequency. The number of waves produced by unit of time is called the distance between two crests, guys. As you can see, it's the same amplitude. The distance between two crests, guys, or two troughs, is called wavelengths, which is the distance between two consequence points. Consequence point means repeated points with the same properties, So let's revise again, guys. Amplitude is the maximum displacement from the rest point. The amplitude of the same wave is always constant. Frequency is the number of waves produced by unit of time. By decreasing the frequency, the number of waves decreases by unit of time. And the wavelengths increase. Notice that the wavelengths increased. Decreasing the frequency increases the wavelengths. By increasing the frequency, the number of waves produced for 1 second increases and the wavelength decreases. The wavelength is the distance between two successive points. Successive points mean points of the same. Here is the wavelength from this point to this point is a wavelength. From this point to this point is a wavelength. Successive points mean two points have the same properties, same phase. Phase means same direction and same position. So here is the wave. If the x-axis represents a distance, so the distance between 2 points represent a wavelength. But if x-axis represent time, so the distance between two successive points represents the period, which is periodic time, the time needed to make one complete oscillation. The distance from the rest point to the maximum point, the maximum displacement, called amplitude. So guys, the wavelength is the shortest distance between 2 points where the wave pattern repeats itself. The wavelength has a measuring unit of meter, while frequency is the number of waves in 1 second and has a measuring unit of hertz. The frequency has an inverse relation with the periodic time. As the periodic time increases, that means the frequency decreases. As the periodic time decreases, that means the frequency increases. So the periodic time is the time of making one complete wave and measured in seconds. As we said, the amplitude is the maximum displacement from the rest point. What is the wave speed, guys? The wave speed is the ratio between the wavelengths and time. As we said before, guys, the speed in general is equal to distance over time. Distance here in waves represented by wavelengths, while time of the wave represented by periodic time. So by the end, wave speed is equal to the wavelengths divided by the periodic time. Which of the following is an example of mechanical wave, guys? Sound wave, because it depends on the medium particles. What is the distance between two consecutive crests in a wave? Is a wavelength. Two similar points have the same phase. Which of the following correctly describes the relation between frequency and periodic time? Frequency and periodic time are inversely proportional. So the periodic time, the frequency is equal to 1 over periodic time. What is the main difference between mechanical and electromagnetic wave? A mechanical waves need a medium to travel through, while electromagnetic waves don't need a medium to travel through. If the amplitude of a wave doubles, its energy quadruple, because energy is directly proportional to the amplitude of the wave, but the square amplitude of the wave. So as the energy increase, this increase will be squared. If it doubled multiplied by 2, so the 2 will be squared, so it will be quadruple. If it trebled, so the increase will be also squared, so it will increase by 9. Here in this question is double, so it will be quadruple. A wave on a string has a speed of 30 meters per second and wavelengths of 5. How many waves pass the point in 10 seconds? A wave on a string has a speed of v is equal to 30 meters per second. And the wavelength is equal to, lambda is the wavelength, 5 meters. How many wave passes a point in 10 seconds? How many waves he needs the number of waves, which is n. Frequency, guys, we said frequency is the number of waves in 1 second. So we can say that if we are able to find the frequency, we will be able to find the number of waves. So V is equal to wavelength divided by time, and 1 over time is equal to frequency. So V is equal to the wavelength multiplied by frequency, which is mean the frequency is equal to V multiplied by the wavelength. So F, V divided by wavelength. So F is equal to V, which is 30, divided by wavelength, which is 5. So the frequency is 6 hertz, which means this wave can make 6 oscillations in 1 second. For 10 seconds, it can make 60 oscillations. So the answer will be 60. Waves at boundary, guys. When a wave reaches a boundary, it's going to reflect back on itself. Exactly like we did here, guys. Fixed end. Let's see what will happen to the wave. As you can see, guys, it reflects back on itself. Notice it again, guys. I'm going to repeat it. I'm going to start. And we'll start now. Make it the oscillation here. It will reflect back on itself. When a wave encounters the boundary of the medium in which it's traveling, some or all of the wave can reflect back or transmit. Reflect back to the same medium or transmit to a new medium with changing its direction or some of its properties, as we're going to study later. The superposition of waves, guys, when the wave reflects back on itself, it's going to form something called nodes. Here is the wave, guys. This wave is going to reflect on this medium. So it will form something like this. This one is called node. And this one called antinode. The node is the point at which the two waves, the original one and the reflected one, cancel each other. So there is no amplitude. The antinode is the point which the particle is still moving and can oscillate. Interference is the result of the superposition of two or more waves. Standing wave is a wave that appears to be standing still, produced by the inference of two traverse waves moving in opposite direction. Interference is a result of the superposition, as we said, of two or more waves. Standing wave is a wave that appears to be standing still, producing by the inference of two traverse waves moving in opposite direction, as we said. In this case, the wave appears to be stopping wave, not moving. Waves in two dimensions. What is the meaning of wavefront, guys? Wavefront is the line, is this line, guys. Here is the wavefront. It's the line that represents the crest of a wave in two dimensions. How come two dimensions? We have a vertical one, which represents crest and trough, and a group of waves. The wave has something like thickness. So group of waves beside each other. So we have two dimensions. The wavefront is the line that represents the crest of the wave in two dimensions and can be used to show waves of any shape, including circular wave and straight wave. Two-dimensional wave always travel in directions that perpendicular to their wavefront. So here is the wavefront and here is the direction of propagation, the direction of traveling the wave, transferring energy. So they are perpendicular to each other. The direction of the wave can be represented by a ray, as we said before, which is drawn at the right angle to the crest of the wave shown in the figure. Which of the following is an example of transverse wave, guys? Well done, water wave. Constructive interference occurs when constructive, that means building, increasing the strength of the wave. Two waves meet in such a way that their displacement adds up. Which of the following is true about standing waves? They require two waves traveling in opposite direction. A wavefront defined as a surface where all points in phase. In phase, that means similar to each other. We reached the end to our session, guys. Just prepare your questions for the live session and study well, guys.